Hello everyone, welcome to my presentation. The research question is what are the key challenges faced by autonomous driving systems that utilize artificial intelligence and ethics, and how can these challenges be overcome? When I was doing research, firstly I read some of the important documents about autonomous vehicles. Then I start to write my report. This presentation has five sections. These sections are Introduction, levels of autonomous driving, types of sensors using autonomous vehicles, challenges, and the future. So, firstly, let's have a look at what is the autonomous vehicle. An autonomous vehicle is a vehicle capable of sensing its environment and operating without human involvement. A human passenger is not required to take control of the vehicle at any time, nor is a human passenger required to be present in the vehicle at all. An autonomous car can go anywhere a traditional car goes and do everything that an experienced human driver does. Today's autonomous vehicles actually not autonomous because they need a human involvement. But in the future they can't need. If we look at the Society of Automotive Engineers standards, we will understand the levels of autonomous vehicles. This standard says there are six levels of autonomous driving. Let's have a look at these levels. This figure was prepared by Society of Automotive Engineers. Uh, to explain its contents, in level 0, no auxiliary system supports the driver in level 0. The driver makes all the decisions and moves himself. Most vehicles introduced to the market 10 years ago can be included in this category. Level 1, uh, level of driving assistance provides assistance in only one direction, acceleration or steering assist. The best example of these systems is the adaptive cruise control or lane tracking assistant. If these two systems work in harmony simultaneously, there will be no level 1 driving because there is support for driving in two directions. We see this level of driving in many vehicles today. In level 2, the vehicle can now drive itself, but a driver needs to be behind the wheel and always ready to take control in case of unexpected situations. If the driver is not ready to drive, the vehicle is planned to pull over to the side of the road and stop. In order to ensure that the driver is in place and ready, weight sensors are used on the seats and the method of receiving feedback from the user through the steering wheel by giving alarm sounds to hold the steering wheel at certain intervals. Today, Tesla and many other autonomous driving vehicles, the first brand that comes to mind when it comes to autonomous driving, are at this level. There is a big difference between level 2 and level 3 because level 3 systems are not legal to use on the streets of the United States. Level 3 is known as conditional driving automation. In this system, the driver does not need to be ready to take control. The autonomous driving system makes its own decisions by using artificial intelligence models in unexpected moments. When you switch to level 4, vehicles can now intervene in the event of an unexpected problem, but the user can take control when he wants. Level 5 vehicles will be able to perform every task independently without needing human presence. Vehicles at this level are not expected to have steering and accelerator brake pedals. Vehicles at this level undergo some tests in various parts of the world, but none of them are on a public road. This is the whole level system of Society of Automotive Engineering reports. Then I researched how can these cars see the world. As a result of these researches, I saw that there are many types of sensors to see a world. Let's have a look at these sensors. Radar sensors. Radar means radio detection and ranging. Uh, these types of sensors sends radio waves to the environment and measures the radio waves reflected by hitting an object with a receiver and detects the distance and angle of the objects and their speed using Doppler theorem. Provides measurement up to 116 meters. LIDAR, light imaging detection and ranging. Uh, its working principle is the same as radar, but here it uses infrared laser signals instead of radio waves. The biggest disadvantage of LiDAR sensors is that they are more affected by adverse weather conditions than other sensors. The reliability of these sensors is discussed, especially since raindrops break the light too much. But the biggest advantage of the LiDAR sensor is that it can scan the surface much thinner and more sensitive than other sensors. Cameras. The biggest advantage of the cameras is they can see the color and form of the world. With this data, it can better identify the warning signs and road condition. Of course, advanced image processing techniques are needed to process these data. The disadvantage of this method is that it occurs when the light comes at opposite angles. Ultrasonic sensors. In this sensor type, the sensor sends sound waves and monitors their reflections. The detection distance of these systems is very short, but this makes distance its estimation at short distance very efficient. For this reason, the parking sensors we use in our cars are an example of ultrasonic sensors. In the left picture, you see a radar and lidar sensors of Volvo vehicle. This little black box contains all of these sensors. In the right picture, you see a front cameras of Tesla vehicles. And this figure shows the range and usage types of different sensor types. After understanding the levels and how these vehicles see the world, we can move on to discussing the challenges about autonomous drive. One of the biggest challenge is to be able to collect data from the environment effectively and to process the collected data quickly. In order to react to emergency situations, even milliseconds are important in collecting, processing, and intervening in the driving system of the vehicle. Even in the most optimal conditions, when collecting data using radar and lidar sensors, the vehicle see a colorless and low resolution world. So it's difficult to understand all the dangers. On top of these situations, it has become difficult to collect data when these sensors are blocked due to dirt on the vehicle or their performance decreases in adverse weather conditions. Using the camera, the function of seeing the world in color can be achieved, but in this case, the performance is seriously reduced in conditions such as reverse light. To solve this problem, the Volvo brand has decided to actively use radar and lidar sensors at the same time. However, since the size of the data to be processed in this method has increased so much, Tesla company has developed deep learning techniques to solve these problems with a camera-based solution. Tesla CEO Elon Musk said, "Anyone who relies on lidar is doomed." He made such an assertive statement. Another huge challenge is ethical problem. These cars can be smart of course, but they can't have consequences. So trolley problem is huge challenge. To explain the trolley problem, let's imagine that there is a trolley approaching the skissers and we are the operator controlling these skissers. If the trolley continues on its normal path, five people will lose their lives. But if we intervene in the skissers, it will change its paths. If it change its path, two people will lose their lives. In this case, what is the right decision is a frequently discussed issue. How to make a decision when the autonomous vehicle remain in such a dilemma is discussed ethically and legally. In order to examine these debates, we will examine the report of the European Commission called Ethics of Connected and Automated Vehicles. In this report, it was stated that it would be more appropriate for the vehicle to choose the path where at least number of people would be harmed if such a dilemma were to remain. By the way, if you think these are not a big problem, you should visit this website. This website is prepared for MIT. There is a two options. Which one is better? If this vehicle do nothing, they hit and five people inside the vehicle dead. If it switched the road, it hit these five peoples and these peoples died. As you can see, it is not easy to make decision. However, ethical debates are still ongoing about what kind of behavior to take against vehicles with some priorities. For example, should our vehicle risk an accident to give way to an ambulance? Another proposal of the European Commission is that the national laws determine who is responsible for automobile vehicles. If an automobile vehicle crash, will the owner of the vehicle, the manufacturer, or the software developer will be responsible? When these ethical and technical challenges are successfully overcome, we will see the fully autonomous vehicles like in the picture. As you can see, this vehicle doesn't have a steering wheel or anything else for humans to take control. Today, as a solution to the processor power, which is the biggest problem in increasing the sensors, solutions are sought for calculating this data in the cloud environment with 5G technology. It will be possible to make instant decisions thanks to 5G technology. Again, thanks to 5G technology, it will be possible for all vehicles on the road to communicate with each other, and when there is a problematic road, the first vehicle to go there will share this information with all remaining vehicles. In this way, the navigation systems of autonomous vehicles will work much more efficiently. Uh, it's all. Thanks for listening. Have a good day.